Okay, so welcome everyone. It's my nth time in Lviv, and I'm not getting bored yet. So today I prepared two talks to you, and they are kind of totally unrelated. One will be a very opinionated view over how and when to use certain frameworks, and the second one will be kind of shallow dive into how inconvenient immutability can actually be. And in those two talks they will mostly revolve around the Java ecosystem, but those ideas are pretty much very universal. So although some examples will be in Java, you don't need to worry about that because they are kind of technology agnostic. So the first topic for today is frameworks and how to avoid them. Actually, it's more about how, why, and if at all avoid them, but this kind of makes a better title. So what we'll be thinking about today is try to think about costs and problems what those new shiny toys can bring us. And in order to give you a bit more context, because, well, often there are no bad advices. They all need to be applied in certain contexts. My context is that I'm leading development of an online casino platform that at the moment needs to support over 1,000 transactions per second in the core, let's say, the core component. We have over 150 services talking to themselves, and around 30 people working on it, at least from the backend side. And if you keep in mind a context like this, we need to. And this is our software. We don't sell it to anyone. We are not outsourced. We are writing software that actually supports the business, needs to earn money, needs to be fast and maintainable. So one of our architectural drivers that we apply is that we optimize for, at least we are trying to, we are not there yet. We are optimizing for maintainability. We are optimizing for autonomy of teams working on the software. Since we are working in a iGaming space, this one is heavily regulated, and those regulations change a few times every year, and we need to be able to adapt fast. So maintainability, autonomy of teams, and the time to market, which means how fast we can introduce drastic changes to our code bases without actually just having it last months or years in some drastic cases. So I don't know if you know this show, but in Poland we have a show called Familiada, where pretty much there are two families competing with themselves, and the idea is very easy, very simple. Before the show, organizers prepare a set of questions, and they send out surveys to different people. And people who answer those surveys, they collect the data, and now those competing families need to come up with what could potentially a statistical Polish person answer to that question. So let's imagine that we are in this kind of space. You go to some conference, you go to Meetup, you meet other friends, and there is some small talk, let's say, emerges between the developers. What people do, what questions are usually asked when you meet your peers on conferences, or maybe when others meet and they ask questions? What do you think? What's often been heard?
Do you write in Java?
Yeah, okay, yeah.
Why Lombok is so stupid?
Yeah, okay. Anyone else?
Something about family.
Possibly. How much do you earn? Whatever. So often what I notice, at least in those like more juniorish conferences, is that often you end up asking questions like, what frameworks do you use? And like it's one of the most important things that kind of decide the success of your software. And I used to do the same. I remember a long time ago, whenever there was new kid on the block, I remember that the Spring with XMLs was pretty cool at one point in time. And it was so cool that we have all those opinionated frameworks where you wouldn't need to write all that boilerplate code. So instead of 3 explicit lines, you could just use one annotation or one XML entry, and suddenly you saved 3 lines of code. It was so cool. Annotations, top of annotations, magic, but it works. You can deliver business value faster. But once let's say my career progressed and I started working with more demanding systems, I stopped working actually in outsourcing, so it's not like we were forced to just deliver something, whatever, in 3 months and forget about this and have some offshore team later take it over and maintain it. Now, my context is a bit different. I need to think about next 10 years that probably we'll need to work on the same software and how to develop it further and how to make it not to turn it into a big ball of mud. So I remember that there was a nice post about Micronaut released in October, and there was one comment that let's say, that kind of resonates with me. Regarding opinionated and unopinionated frameworks, I think they appeal to different types of developers. I now have 20 years of experience. In my 5-8 years, I loved frameworks like Spring. However, as I gained more experience, I felt I needed a framework's opinion less and less. Now I avoid them. And this is something that I actually I can fully sign off of it, because over time, notice that the more magic you have in your software, well, it's okay because, well, you can ship stuff fast in the initial stage, but then over time, once the frameworks progress, old versions become abandoned, it becomes more and more problematic. Plus, then you have new people joining your teams, possibly some of them are juniorish, that they don't yet know all possible surprises that you can find, for example, in certain Spring versions, and you end up with trouble, which within months something on production starts working. But before we do that, let's do a short quiz. Have you ever seen this image, this painting? Yeah. Do you remember who made it and what's the title?
This is Picasso.
That's not Picasso.
Oh, Dali.
Yes, what's the title?
Frameworks.
Quite close. The title is Scala Programmer Confronts Java Project that uses Maven, Spring, and Hibernate. Yeah, that's not a real title actually, but there is some really cool page actually that aggregates classical programmer paintings with stuff like that. So definitely check it out. But as someone that at some point, let's say, infiltrated more than one community, not only Java but also Scala, also I can fully sign off of that. Because if you at some point start looking at, if you go out of your local ecosystem and start seeing how others are doing. So tools, the config tools like Maven, all those opinions, dynamic proxies, annotations from Spring, and all the magic and the bloated Hibernate brings becomes really scary. I started playing with Go recently, and you can have your web server running pretty much like 3 lines. With one static binary, with no runtime dependencies, compile, and the Docker image that can run it, and that weighs 10 megabytes. Try the same with Java applications. But before we go forward, let's actually try to define what I mean by the invasive frameworks that are actually the title of the presentation. So I would say that invasive frameworks are all of this actually rely a lot on magic. And many of you might say that magic is just a piece of technology that you don't understand. But if you compare, let's say, different technologies or different paradigms that you could use, let's say, in your code, there are certain technologies that require, let's say, more intellectual effort to grasp and follow. So, for example, if you have, let's say, if you want to surround your method call with logging, you can do that using, well, you can just put 2 additional lines of code around your statement. Or you can involve dynamic proxies into that aspects. Which one will be harder to debug? Yeah, there is not that much to debug if you have 3 lines, but if you need to debug dynamic proxies of classes that actually that exist only at runtime, that becomes a bit harder. So, if I was trying to point out a few, let's say, forbidden black magic techniques, that would be something like runtime reflection, class path scanning. So all Spring Boot fans out there, it might look fun if you add just one jar, but then it gets auto-configured. Too bad if you go to production on H2 instead of your database because of auto-configuration. All stuff related to thread locals. Nowadays, due to the popularity of Project Reactor and async, this becomes even much harder if you jump between threads, and thread local context doesn't really exist, and doesn't really make sense. All kinds of runtime annotation processing, proxies, aspect-oriented programming, and all of that. The thing is, those techniques are not really evil by themselves. Okay, they can bring a lot of good stuff. But usually, once you combine them all together, you end up with a bit of a messy thing that's really hard to debug. What's quite interesting as well is that if you go, let's say, to the Spring Boot, Micronaut, or other tools like this, if you read one of the main pages, you will have a big bold statement that some promise that the framework will actually solve all problems for you. Just use your domain classes and extend classes from the framework. Just put some annotations over there, wire up some annotation processors, and it will be cool. But if you, let's say, jump for a second in a Scala ecosystem, well, you will see that most of tools, they are actually described as that's not the framework. It's just a toolkit. Use it, do whatever you want with it. We don't want to do anything. We don't want to do any magic. We don't want to manage your code. Well, there are some exceptions like Lagon, but generally, I would say that this is a trend, and this is actually quite a common pattern, because if you see, let's say, recovering Java developers that go into Scala, they figure out, I mean, where are annotations, where are aspects and dynamic proxies? Well, they can be, but it turns out that you don't need all of that to achieve the same functionality. For example, aspect-oriented programming becomes, let's say, quite a lot, let's say, deprecated after we got lambda expressions in Java, because, let's say, patterns like template method or execute around patterns are become so easy, so cheap to implement that you don't need to bother with wiring your aspects and playing around with that. But let's not praise Scala too much, because they did a lot of bad stuff as well. All the hell with implicit, and this is exactly the same problem to end up with Spring and auto configurations. So it's not like they got everything right. They got a lot of stuff wrong, and the Scala 3 will be totally different from Scala 2. So let's remember about this. Also, keep in mind that we are in kind of small groups, so if you want to ask questions or challenge something, just feel free to do that immediately. No need to wait till the end. So before we go forward, let's also spend some time on trying to establish the language, establish the bounded context. What was the difference between framework and a library? At least in the Java space, I see them being used interchangeably quite often. So a framework is something that puts a work into a certain frame. And so let's have a look at the context. That's the example of a Spring Boot. It's something that manages the whole runtime of your application, starts your classes, kills it whenever it wants to. Your job is just to provide the content of those classes, configure, and everything is managed for you. When it comes to libraries, that's actually quite different. The code doesn't sit within the framework, but it kind of reuses one of the tools that's given for you. And the cool part about this is that if you wanted to have features, let's say, from multiple frameworks, that gets kind of difficult, because it's really hard to combine, let's say, a few tools that actually want to manage your code, its life cycle. It becomes kind of hard, although I managed to find some pieces in our code base where some very smart people managed to combine, let's say, Jersey with Spring, with some custom, let's say, really scary code that rewrites, let's say, context from drop wizard to Spring, and then uses Jersey. Yeah, really crazy stuff. Anyway, the concept of a framework exists way beyond the software. So, for example, all kind of franchises. For example, McDonald's. Let's say you want to open McDonald's. It's a out-of-the-box ready framework for a successful, let's say, food. It's a restaurant, food provider, or factory, whatever. Another thing would be some project management methodologies. For example, Scrum. Scrum is a framework. I mean, you wake up at 10 a.m., you meet for 5 minutes, then on Mondays you plan, on Friday you retro, and you will succeed, okay? The thing is, if you work with Scrum, it's actually, I've seen some companies that do it by the book and to go into a really weird spot. But if you don't like certain things, it's very easy to change. You can change it whenever you want to. You figure out that, let's say, the poker planning cards doesn't really work, you just throw them away and do something else. But it's a bit more strict if we look at the example of a McDonald's. So For example, imagine that you open your own McDonald's. You want to use the same framework, but I don't know, change logo from yellow to green, whatever. Now it's not so easy, because the contract obliges you to actually follow all the frame that was given for you. You are not supposed to change stuff, you are supposed to follow it. And now this is the moment where you realize that if you really want to have your independent business, probably going for the out of the box or the franchise, it's not so good. Kind of the same happens with frameworks, with all frameworks that are very, very stiff. And usually most of the opinionated frameworks actually are in this case. So the main problem with frameworks that usually I have is that in order to be proficient with Spring Boot, Quarkus, Micronaut, whatever is popular right now, you need to spend some time, you need to invest time into learning that. But they outdate quickly. Okay, the volume of changes that are happening in the ecosystem is insane. You take a few months and you have a totally new set of tools, new set of opinions that you need to learn. And it's okay, but we have kind of, let's say, limited time in our lives. So after work, you could spend your time on, for example, learning the distributed systems, let's say, or you can learn just new opinions that Spring, let's say, new Spring gives you in order to be productive. So at the end of the day, choice is yours. But if you learn, let's say, distributed systems, that will be, let's say, this knowledge will have more applications than just the opinions of a framework that might outdate fully. The problem with certain frameworks is that they actually own you. So once you have your domain classes, let's say, extend framework classes, once you have annotations all over the place, all those implicit configurations, it becomes much harder and harder to actually step out of it if you want to. Let's say you don't want Spring, you want Quarkus because it boots up really fast and it's generally very lightweight, but it's not so easy. Okay, you need to rewrite pretty much everything. It will be very hard to do this step by step. So at the end of the day, we end up with legacy because the cost of rewriting is probably not worth it. All those magical frameworks, they also increase complexity and often complexity and weight of applications. Actually, Java space is getting it getting much better with that because those new tools like Quarkus are quite impressive. But if you look at Java EE, all those, let's say, web servers that weigh 9 gigabytes, and that becomes really hard. Even if you look at what the Java is doing, the runtime is doing. If you start up your own, let's say, Spring application, empty Spring application, it boots up a few seconds, takes, let's say, 100, 200 megabytes of RAM. That's kind of a lot to start with. And what's kind of interesting is that often when you take well, it waits because it brings a lot of features, a lot of magic in there. But maybe you don't need all of them. Probably in most cases you need just a small subset of them. But you still pay the cost of having all of them in there. Again, Java EE was fun, was cool some time ago. Then the Spring appeared. Spring was cool, but kind of the history repeats itself, and Spring suddenly now becomes, well, kind of this big platform what actually it was fighting, many years ago. It was fighting Java EE, and now there are other frameworks rebelling Spring, which became kind of what it overfought a long time ago. And well, soon it won't be a cool thing. You will need to start learning new opinions. So better get ready for that. So again, you need to make sure that you keep up with all of that to be productive. Officially, even if you migrate, minor versions, they shouldn't change, they shouldn't break anything. But the stuff happens. For example, recently we migrated Spring from 2.0 something to 2.1, I think, and well, tests went through, everything went through, all looks good. No one touched the service because we didn't need to, and there was some production issue. And then we go to have a look at logs and metrics in Grafana, and oh, they are gone. It turns out that the one of the, let's say, default opinion of how it reports, let's say, metrics, the format of metrics is slightly different. So, not really a tragedy, but stuff like this happens. And then imagine that you actually couldn't migrate to the newer version, and the older one actually gets outdated. This is where you often need an expert help. This is where you call Pivotal, you call someone else, and they go to you for, let's say, $1,000 or $2,000 per day, and they go and try to help you with, let's say, dealing with your legacy Spring version. This is where you actually start. This is where it becomes actually very, very expensive. We had this problem when we're dealing with Axon 2 and Axon 3. Actually, I haven't witnessed it, but I heard the stories that we had consultants trying to look up how we could migrate from Axon 2 to Axon 3, but pretty much they looked at it and said that yeah, it's just very hard and yeah, not worth it. And this is how we are stuck with Axon 2 at in some services, and it's really hard to get rid of. And it generates a lot of problems. Some of them were solved in Axon 3, but yeah, that's not that easy. And keep in mind that frameworks often give you way more than you actually need. And this is usually when you get there is one very common question that gets asked, which is, Grzegorz, wouldn't you like to actually focus on solving real business problems and let framework authors do the boring parts? Of course, the problem is that all non-trivial abstractions to some degree are leaky, and this is what George Polsky noticed in 2002 already. That the wider the abstraction, the bigger chance that something will leak out from the abstraction layer below. There are some very good ones like TCP, but then you have, let's say, ORMs, which are not that cool and leak out all the time. So what if we would spend that time on actually not learning someone's abstractions that are leaky, but actually understanding the underlying technologies that would allow us to be much better at what we do? And the ORMs are a great example. Actually, it's quite amazing how in Java space JPA and Hibernate is treated as a default, pretty much like in our folklore is a kind of some form of a standard. Because look, the problem is that in order to be very good with Hibernate or in JPA in general, you need to know it really well, and there is quite a lot of corner cases out there. But in order to be really good with it, you need to understand what is going underneath. So you need to know SQL as well very well, and databases, what's going on in there. What's the point in investing in ORM if you need to know if you need to learn two things and not only one? Does it really bring you that much value? By the way, how many of you worked with Hibernate or worked in the past? Okay, how many of you liked it? Okay, you see the point. So, plus, what's more actually? If you go out, and look at tutorials, let's say introductions to Hibernate and JPA, you will see quite a lot, let's say, bad practices being, let's say, promoted. Usually those are not consciously promoted, mostly like just people taking shortcuts. But what you can also often see is that, they will take, let's say, the domain classes of your application, put a lot of annotations in there, and suddenly, look, we can persist everything. Then they will put, let's say, Jackson annotations, some other annotations, and you end up with such, as some people call it, rich DTOs. The problem with that is very hard to evolve that, and it's very hard to break out if you have, let's say, the same, if your domain model kind of is used pretty much for everything. It's not only a representation of your domain, but also a persistence model, but also how the representation of what you return, let's say, from HTTP controllers. And this is not really also a problem if you put those annotations over there, as long as the model is simple and graspable. Right? Because this is a nice example. If you want to persist a user, you just put one annotation entity here, you put a column here, and you can save it. By the way, what does annotation column do in this case? Do you know?
Create a column.
No, it does actually nothing. Testing your Hibernate knowledge. If you try to persist a class like this, it will persist, by the way, by default all field.
In this case, yes, but in other case, it can rewrite the name of the column, right?
Yes, but in this case, if you don't provide any name here, then it does literally anything. But I still keep seeing them in the code pretty much everywhere. It's like, I would say that 90% of Hibernate classes, they have those empty column, let's say, annotations that do literally nothing, because it all gets persisted anyway. So, as you can see, there's quite a lot of, let's say, at least I believe that kind of the Java community is slowly realizing that, or that Hibernate is not the holy grail of what we can do with persistence. There are also kind of satiric sites like this one showing what can it end up with. And yeah, one annotation was pretty easy to read. It's too bad if you combine it with a lot of others. Now, imagine that all of them are read by some of annotation processors that are also aware of other annotations. That becomes really scary if you think about trying to debug that.
It's a real code? It's a real?
No. I mean, yes. I mean, look, yes. Yes, look. Does this even mean anything? Of course.
Annotation, you do not talk about one.
Yeah, Fight Club, lol. By the way, wait a second. I have a joke for you. Do you know how many dBAs are needed to replace a light bulb? One too many. Okay, never mention this to anyone. So, the cool part about SQL is it's fully complete, it's fully declarative, self-sufficient. Too bad it's not type-safe, right? So there are libraries out there that actually solve this problem. Solve the problem of SQL not being type-safe. So you can easily drop your Hibernate. And to be honest, I've seen so many Hibernate usages today where you just write directly native queries. What's the point in there? So, for example, one of the tools like this is JOOQ, or pronounced Juk. And this is pretty much the library that solves only one problem. It gives you, let's say, it's a type-safe query builder. It unfortunately needs to generate a bit of code, but at the end of the day, you can write your SQL statements using a very cool and easy to fluent API, which is great to use. If you are working in the Kotlin space, you have something like this available fully for free, which is Kotlin Exposed, which works pretty much the same, but luckily doesn't involve any code generation. You don't need to do that at all. I don't really know how is this generated, but it's pretty cool. We used it in production, worked really great. But if you are working with Spring, there is a huge chance that you already have a very powerful tool for your persistence layer, which is JDBC template, which is often very overlooked. It's as easy as it gets. It's pretty much a handy tool that allows you to use JDBC in a, let's say, way that not a painful way. So imagine I want to take, let's say, all movies, all entries from the movie table. I write my native query over there, and I provide a mapper. A mapper is something that takes a result set and converts it into an actual object. And the mapper is just, well, it's a bit of this boilerplatey boring code. But over the years I learned to appreciate the boilerplatey and boring code, because if something goes wrong, there is not that much place where it can go wrong. If you start debugging this, it's very easy. You see the problem immediately. But if this was happening somewhere magically, somewhere along the way, that wouldn't be that easy. Plus, this will be really fast. So that's pretty cool. Another thing is that even if you decide to adopt certain frameworks, they will be as invasive as you let them be. Unfortunately, there is no like golden silver bullet recipe how to let's say make frameworks hold their horses. But the very simple way, let's say, if you want to work with Hibernate and JPA, if you really want it, is to forget about, let's say, putting annotations all over your domain model, but use the ORM and the Hibernate as a persistence plugin to your domain. Then you create your two separate, let's say, models, and this will involve all this bad duplication, as you might say, because, well, you have private long ID, you have long ID, you have private string name all over again. But there is a lot of misconception about the don't repeat yourself rule. And I noticed that in big systems it often actually creates more problem if misunderstood. So for example, a common pattern seen in big systems is that you have some form of common or shared libraries. Some times you end up having domain classes in there as well, some HTTP clients and all over the place. And let's say you want to have some form of default value returned, let's say when your HTTP client reaches for something and reaches there. And then you end up with junior person jumping into the code base, remembering Uncle Bob and don't repeat yourself. So, and then then this check lands in a shared library, in a shared HTTP client. And then some other people start don't use the HTTP client, but write their own to call the APIs directly. And this is where it slowly becomes really unmaintainable and really, really sorry, because we had situations like this on production where in our space, in a casino space, if you are not one of the regulated countries, you all fall into the, let's say, called MGA license, which is the Malta Gaming Association. And we had some of this logic put into a HTTP client that was shared all over the place. Some wasn't. So, and something like this can end up with pretty much business going down, because those can be, for example, license breaches. And if you lose, let's say, MGA license, you can't serve, let's say, most of the world, which is pretty sad. So remember that you can use all of that. Just remember to keep it separated. Remember that besides don't repeat yourself, you need to make sure, keep something in mind like coupling. Maybe it's not worth to use the domain classes for everything. Maybe it's worth to sacrifice the don't repeat yourself rule, only to make sure that you have then isolation between persistence and your domain level. Because look, if you want to rewrite the Hibernate-based persistence, you just throw away the whole package and you write a new one. And the domain remains unchanged. The logic remains unchanged. So it's something to learn here. Even with Spring, we can do quite a lot of stuff to make it, let's say, as least invasive as possible. And actually most of our services, and I'm telling you that Spring is bad, but most of our services use Spring in a quite safe way. We just don't rely on its magic a bit too much. So let's have a look at a very, very simple example, which is a typical configuration of some application, where you have, let's say, you have some annotations taken from Spring, you have some facade, you register it as a bin, you index, let's say that after construction you want to call certain method and so you put a post construct method on that. But now you already have some signs of a tight coupling with the framework itself, because the framework instantiates it in some unknown way. There is no constructors. It injects some fields through some no one knows how. Then the lifecycle is managed using the post construct method. So once you think from the perspective of a potential consumer of the class, you want to instantiate it in a, let's say, in an old and boring private static void main class. And it's not that easy, because you need to remember that you need to what you need to put in what order. Sometimes it's not possible at all in certain frameworks. Plus, all those tools that you used, it forced you to, let's say, loosen on certain good, let's say, coding practices. Because, well, look, you can't have a final field over there. It all needs to be mutable. There is no proper encapsulation because, for example, in case of Hibernate, you need to have public classes everywhere. So this is not cool. But there are some steps that we can do to make it a bit less invasive. And one of the examples is one of the easiest way you can do it with Spring is to use constructor-based injection, which is already, let's say, a recommended approach even by the Spring team. The Spring team even Spring team doesn't believe that you should go this way and let's say sacrifice all your classes to Spring. And it's a very easy way. Suddenly you create your own constructor and you actually do dependency injection by yourself. In our space, for some reason, dependency injection is kind of immediately associated with having some form of container that actually manages all the dependencies for you. But actually, dependency injection, all dependencies, let's say, pulled out to a constructor because you inject dependencies in there. It can be done by a container, but it doesn't need to be. So Finally, we have a public API. This is the public API of a class, and now we know how to create a formula to create an instance of it. And now, if we put AutoWired on the constructor, now we force Spring also to obey the rules of that class and use its public API, which is much better. You finally can clearly and easily, let's say, instantiate an object. Although you still need to keep in mind that there are some methods that need to be, let's say, run manually if you want to end up with the exactly same state as the starting point of the previous example. So look, we managed to encapsulate our internals. We can instantiate it independently. The coupling is still there, but a bit, let's say, lower. Also, in the newer Spring, actually, you can get rid of that, so there are no traces of a framework in your code at all. The next stage would be to actually maybe get rid of the post-construct method, because, well, it's quite handy if a post-construct can actually run a method after a construction, but if you have one constructor and we don't put any more Spring magic in there, well, you can actually use the very boring old way of actually calling the method yourself. And now, look, from the perspective of someone that consumes the API, it's much easier, because you don't need to worry about a lot of stuff. You just construct an object, providing dependencies, and all is done, let's say, for you somewhere in there. And the last thing you can do in this space is to leverage something like Java configuration classes in Spring, which means we can totally get rid of any, let's say, string annotations from code. We have a dedicated class, dedicated configuration, which has, let's say, a few bin annotated methods, which actually construct the whole context of your application. But if you actually start thinking about the encapsulation and, let's say, modularity at the package level, in this case, the full facade class would represent, let's say, would encapsulate a set of, let's say, other classes, other functionalities in a one particular module. The question is, do I really need to expose full service in there if the facade is the main entry point to the whole my unit? There is no value in that. Why even do this? You can wire it well the old boring way by yourself. Just create class, pass it over there. And this becomes much easier to manage later on. If you want to get rid of the Spring or write something in tests, you can just take this code, let's say, or make it a static method that actually wires up your whole, let's say, context, and it becomes much easier and much more maintainable. However, there might be some traps in there, because Spring and other tools like this that rely on magic might actually not like this a lot. So, for example, if you want to have let's say, imagine that full service has some methods annotated with transactional annotation. That won't really work, because it's not managed by Spring, right? It won't create a proxy underneath, because, well, it's not aware of existence of that file, of that class. Imagine that, let's say, you have use methods like timed annotation that, let's say, gathers metrics of usages of certain methods in a class. That won't work, because the Spring doesn't know that there is some full service in the context that it needs to inspect, let's say, and use some aspect-based magic to actually write all of that. So you need to be aware that you need to be careful with that, because kind of Spring and tools like this will rely a lot on having all of those methods actually managed by itself and being in one context. But if you don't rely on this magic, you don't need to do that, because, well, at the end of the day, it's just one simple class that gets instantiated. So as you can see, we have two examples. We have same functionality, same framework, written in an invasive and kind of non-invasive way. In order to be non-invasive, you need to write a bit more code, but there is some value in having a bit more code, but being decoupled from the framework. But you need to use this knowledge and apply it in your own context, because, well, maybe you want to ship something very fast for a client from Germany. The deadline is for tomorrow. Then you just put annotation over there, ship it, and let someone else worry about this. Maybe that's your context, and it's okay. So, I don't know if you heard about the concept. But have you heard about hexagonal or clean architecture or onion architecture? That's kind of very close to each other. Okay, good. Good that you don't, because you will learn something. So hexagonal architecture or clean architecture, this is not really a top level architecture. It's not like it's not something that tells you how to organize all your services, doesn't tell you how to organize everything, but it's a concept where you keep the domain in the center of your application, which is clear of all frameworks, tools, as much as possible. It represents the logic of your application, what your application actually does, and it exposes ports and adapters to outside world. So instead of having, let's say, Hibernate annotations put all over the place of your domain classes, which represent actually your problem that you are trying to solve, let's say you have an interface called, let's say, user repository. And the domain relies only on the interface called user repository. It doesn't know where the users come from. They might come, they might be taken from database through Hibernate. They might be taken through database with JDBC template. They might be taken through some another service using some HTTP client. They might come, from homing pigeons and some people actually putting this over there. It's not important. Your domain doesn't need to know about all the details. It needs to know that there will be some pluggable mechanism that actually provides you users. And once you start using the concept and making sure that your domain is, let's say, agnostic of tools that you use, suddenly those things that you write become much more maintainable. Plus, become much easier testable. Because you don't need to suddenly write up all your context to test a very simple thing. You can have a mock-up, let's say implementations of a in-memory repository. You don't need to rely on H2 to test the very basic, let's say, flows in your application. And those tests run really, really fast at the unit level. So this is really cool. Of course, you need to test integration later on, but you can have a set of unit tests without mocks that test actually quite a lot. And this is where I'd like to tell you a short story about how we fought with Axon, RabbitMQ, and the Kafka story. So Axon in Axon 3 they fixed a few things. They kind of use database as Kafka in the kind of same way they use, but we have a lot of experience with Axon 2 and how some things went wrong. So the story goes. We decided that we want to we use RabbitMQ everywhere. At some point we figured out that RabbitMQ is very hard to scale and provide proper resiliency and high availability. That RabbitMQ effectively is a single point of failure in our system. We wanted to do something with that. And Kafka seemed like a reasonable way to move forward. But we fell for the promise that Axon gave us. We had Axon pretty much in all services. It promised the evolutionary architecture where you start with a monolith and then you just pull out the services, modules somewhere there, and then you have microservices suddenly. We ended up with one very big, let's say, ball of mud because of this. And we wanted to migrate to Kafka. Here's the problem. Axon allows you to, let's say, do a very simple logic like event handlers using just one annotation. Okay, if you want to route your message from some message broker, you just put an event handler on a method and that's all. Okay, so convenient, right? The problem is, why not do the same with Kafka? Okay, so we plug in Kafka and we hope it to work, and oh, there is no Axon Kafka module. What do we do then? It turns out that, well, we have a few options. We can either go to guys from Axon and ask them to develop this for us, which would be crazy expensive. Well, Axon is open source, so we could have our own people actually go and write it by ourselves, or do something else. And we actually ended up at some point going with sacrificing one of our people that would just go and write the Axon Kafka module, but we never ended up using it, because meanwhile, we came up with a better solution. The solution wasn't try to fix Axon, the solution was try to get rid of it. But how we can get rid of that? Okay, because we have those event handlers and methods, and let's think what we could do in order to actually not use a framework in this case, but let's say take the ownership of the whole routing to us. So what's such an event handler? that has, let's say, annotations on methods and the routing based on some event types. Effectively, that's just an interface. Let's say that's just a map where you have a key routed to some action, right? Well, that's not complicated, right? That's just a map. We can populate it. We can build our own routes. So we have one route, second one, and due to Java being kind of, let's say, the Java limitations, we ended up with a bit of redundancy over there. So we need to skip on that, but we have some routing key. We need to use we use this class, and we route it to, let's say, player session ended, which is here. Same with the second one. So it's effectively the same logic expressed using, being explicit using our code that we own. And the cool part about this is that it's very easy to test, because let's say if you let's say take all of this and give it to Axons and its context, in order to be able to test it, to wire all of that, you need to bring up the Axon and Spring's context, where all of this is wired. And this will be potentially slow, and also coupled to Axon and Spring. But if you have all of this here, if you own it, it's very easy to test. You can test it at the unit level, which will be, again, blazingly fast. You can have like thousands of such test cases being generated, let's say, within 1 second and performed. And regardless of what framework you use, you can switch frameworks. This will become stable and won't change. Okay, let's see how would the potential routing actually look like. This is a simple, let's say, event listener that reacts on a message. It takes a route of a message, checks if it's non-null. If it's non-null, it routes it to an event handler that was in the map. If not, warns, which actually should never happen, pretty much. That's not so difficult, right? That's not a lot of work. And then you write a similar, because this one is Rabbit event stream. Then you write something very similar, but for Kafka. You write similar stuff. So you have you write your own connector for RabbitMQ, for Kafka. You write a similar logic. Let's say, Kafka represents, let's say, those in a bit different formats, so you need to do some pre-processing. But at the end of the day, you have Rabbit stream listener and Kafka event stream listener, which those are two pluggable mechanisms into our system. And then you can easily create a bin, let's say, of some Rabbit event stream listener that listens to some RMQP topic. And you can do the same for Kafka. And that's all, okay? And look, now, based on the profile, you can actually switch between one and the other. You get rid of the framework at all, you own the logic, and now it's fine. And this is how we switched to, well, we never actually migrated to Kafka because of other reasons and other priorities. But once the day happens, we just change the Spring profile, and we go to Kafka, okay? And we don't need to rely on any framework. And this will give us quite a long-term maintainability. We don't need to worry about bumping, Axons, migrating. This is all there. This won't change. So we built it. I think it took us less than 1 day to build all of that and push it to production. But the guy building Axon Kafka spent on it months, okay, and then left to Confluent. But that's another story. So as you can see, well, sometimes some solutions end up being much easier than trying to actually, like fight with magic. One of the things you could try and explore and have a look at is Ratpack. Ratpack is not another new big magical framework. It's just a set of libraries for building scalable HTTP applications. And again, it's a collection of multiple tools that you can try playing with, which is pretty cool. I encourage you to try this one. If you want to see how an example, let's say, server looks like, it's a bit of code without too much magic. There's just a server configuration, some registry of, let's say in this case, juice, some paths being configured, and that's all pretty much. It might be pretty ugly because, well, so much code that we could have done this with annotations, but it's static, so it's very much easier to maintain and discover what actually is going on. And don't worry, very, very big. There are ways to, let's say, make it readable again. So we are slowly getting to the end of the first one. Remember that at the end of the day, remember to take into consideration your own context. Remember to use the common sense, because it's the ultimate silver bullet best practice. And at the end of the day, remember that probably business doesn't care. This is your code on the library you used. One thing, there is one very interesting rant from a Russian guy about the state of our, let's say, industry and how we write software, that we often get into our hands, let's say, very precise scalpels, and if we want to make holes in the walls, instead of using them, we just put like 200 of them in the bucket and throw them at the wall. So definitely worth checking out. It's the Russian guy is a bit angry, so just remember about this. So thank you. I hope I managed to provide you a bit of food for thought. If you want to find me on Twitter, I'm right here, and I forgot I have a second one. Okay, and see you after the break.